Welcome back. Today we are looking at what looks to be a very, very clean 1965 Deluxe Reverb amp. Very nice grill cloth still in place. I was told this is a 65, that it maybe has a bad power tube or something similar. Let's go ahead and flip it around and see what the chassis says. Okay, this does in fact look to be original. We've got a A06539 serial number, so I believe that's 39th week of 65. This is going to be the AB763 circuit. Oh, yep, and we've got our intact tube chart there. Looks like we have a non-original 3-prong, so expecting to see probably filter capacitors changed as well. Not recognizing this speaker, although it could just be one of the original speakers that has the label. There's definitely a mark where there was a label there. I'm not, to be honest, very great on recognizing speakers from these eras. I always have to look it up, so someone may know better than me in the comments on that. Let's open this thing up, test the tubes, take a look in the chassis, see what's going on. Okay, the chassis is out, and we do in fact have a very clean 65 Deluxe Reverb with all of our transformers matching. You can see 606 being the manufacturer code for the transformers, and then that 5, this being 65 13th week, 65 12th week. This is upside down, but it's also 65 13th. And then our chassis has a 65 20th week. So this checks out as being all original so far. Let's open up the doghouse and see what we got underneath there. Okay, not original caps, not necessarily what I would put in, but still done, and looks like they probably were done correctly. Things seem to be secured, so I think they probably did add a little bit of silicone there, but just enough that it's not dripping all out and all over the place. Okay, let's flip this thing over and see what's going on. Today in interesting amp decisions, we have this Deluxe Reverb that has had our cathode bypass resistors replaced, as should be done in an amp of this age. The blue molded caps are still there, which these typically are good. These do not leak nearly as much as like the older Astron style caps. I typically leave these in place unless I have a reason to suspect that it's a very leaky one. So that's not bad. We do, however, have an interesting looking bias cap. Now, the resistor has been changed in the bias circuit to a metal oxide style, which that's great. I'm not sure if this is a new resistor and I've just never seen this type before, or if this is an old style electrolytic. The only other thing of note, I've tested the screen resistors. These have also been changed out to metal oxide. Good call. These operate much better under high heat. They will retain their value much better than something like the carbon comps that are below there for the grid stoppers, which are both pretty far out of spec. I believe these should be 1500. This one measured right at 2K. This guy was at 2500. So ideally, those should probably be changed out. Now, I'm not sure that's our problem. Based on what the customer described, it sure did sound like a bad power tube. However, I tested all these tubes on the tube tester. They all seem fine. A couple of the 7025s in the preamp were a little bit low on life, but as I've said before, these old style mutual conductance tube testers can really only tell you if a tube is definitively bad. They cannot tell you if a tube is good. So we could still have an issue. I'll probably go ahead and test this rectifier as well, just to be sure. Got a little, speaking of, I don't know if you can see that. Can we focus? Yeah, a little burn-in, probably from whoever changed this out, which they did a good job. They left the earth ground longer than the other wires. We'll have to check out the actual connections, but things look good. Got a dedicated ground there. Okay, I am going to dive in a little further. We'll power this thing up on the bulb limiter, see what happens, check some voltages, see if we can hear anything that's off. All right, so we're about to power this thing up on the bulb limiter. We're hooked up to my attenuator as a dummy load. Got that guy turned on. I did find that the fuse was a 2.5 amp fuse, which on this amp it should be a 1 amp slope low. So hopefully there's nothing else that was going on in here that was having an issue where that fuse should have blown, but didn't. That's one of the few things that can take out your power transformer, is putting a too large of a fuse into an amplifier and then having an issue that causes further problems because the fuse doesn't catch it. Okay, so we're going to power up on the current limiter, and assuming everything is okay, at least to the point where we can do some voltage measurements, we'll go ahead and do those. But let's see what happens here first of all. So I'm going to watch my light bulb to see if we get a light that stays bright. Okay, and so far we're looking good. The bulb came bright and then dimmed back down, and that's from the inrush current of the filter capacitors coming up to the point where they're charged at voltage and are no longer passing any DC. They are just going to stay at their charge point and then act as a reservoir. In fact, they used to be called reservoir caps in these positions, for the same reason that they act like a water reservoir, where when there's a large demand for current at the tubes, they can backfill that and then charge up during the next power cycle when they are not in demand. Okay, so I think we're looking okay. Let's see if you guys can see my meter there. That might not be the best spot. Let's go ahead and put it here. And I'm going to take my ground probe and attach it to the chassis, as we do. Use my red probe on DC volts with my left hand behind my back. And excuse the wiggle there. Okay, so let's first of all check out our power tube sockets. Okay, so we're getting some bias. And I can hear some static when I'm doing that. Let's see. $272, $273. And again, we should have basically the same voltage on either side of the screen resistor when things are at a standstill. Okay, yeah, and the bias is relatively stable. Let's see what we have. So we'll check pin 1 and pin 6 for our plates on the preamp tubes. And again, these voltages are going to be lower because we're on the bulb limiter, so I'm just looking for ballpark kind of figures here. Okay, I'll still see that. Okay, that should be all right. 270. Things so far are looking good. which means we may have an intermittent issue, which are always the worst ones, or at least the hardest to track down. Okay, voltages all look good on the plates of the tubes. So let's grab a guitar and see what this thing actually sounds like at this point. So we are hooked into the vibrato channel first here. Okay, so this thing's sounding fine so far. I might let it heat up for a little bit here and then see if any issues pop up, but I couldn't get anything to pop up with a chopstick test. Voltages for the power and preamp tubes all test good. Maybe a matter of just recommending a few things. If this was my amp, I would change out quite a few of those preamp tubes that tested low. I would be changing out the screen grid resistors that I pointed out that were testing outside of tolerance. Probably would change that bias cap. If this were my amp and I was gigging it, I would replace the filter caps just because. Just know where they're at and put in a brand that I trust a little more in there, like some FNTs. But otherwise, things are all looking pretty good. This thing's very clean and sounding as it should. So I'll let it sit for a little bit and report back if anything pops up. All right, so talk to the customer on this guy. I cannot seem to get it to fail. There are a few issues that we've identified as possible sources of a problem, namely the grid stopper resistors being out of spec. One of them at just under 2K, the other at right under 2,500 ohms. And then this bias pot could be an issue, but I talked to him and he said the issue seems to pop up sometimes right away, sometimes after an hour or so playing. Let this thing heat up for about 40 minutes to an hour. Still sounded good. Poked it with the chopstick. Did all my normal tests to try to find a cracked solder joint or a component that was failing under heat. Still no luck. So unfortunately, I think we're going to call it here for this video. My next step is going to be to put this thing back in the cabinet and crank it, let it sit for a while, see if there's some kind of vibration issue that I'm not able to simulate on the bench, despite getting in there with the chopstick to poke at the board and poke at components. My assumption at this point, or my next best guess, is that there's a tube that is failing, or that is, some of the tubes are relatively microphonic. If I give them the tap test, you can hear them, or even tapping the heater wiring, you can kind of hear that ping come through. So there is a chance that one of these tubes is rattling or vibrating at a frequency in the amp when the amp is being played, which is then causing the microphonics to feed back. But that's kind of a crummy, I don't like telling a customer, well, you got to replace like all your tubes to maybe fix this problem. I'd rather find the issue or try to pinpoint it down a little further than throw in, $200 at a shotgun approach. So I am going to throw this back in the cabinet, and we're going to fire it up and do a sound test, which I'll post for one of my Saturday sound checks. And then hopefully either the problem will pop up as part of that, and we'll do a little follow-up, or otherwise, worst case Ontario, we just got a good, nice look at a 1965 Deluxe Reverb. Very clean version of this circuit. Yeah, so always good to see. Either way, thanks for watching. Hope you all are having a good day, and we'll see you on the next repair.